Welcome everyone. I always try and find articles, technical articles on technology and different things. There is a new browser tracking hack. Works even when you flush your cache or go incognito mode. So there is the use of these favicons. They're tiny icons that websites display on users' browser tabs and bookmark lists. And apparently, these little favicons can actually store information separate from your typical browsing history and cookies from your browser. And so websites can abuse this arrangement by loading a series of favicons on a visitor's browser that uniquely identify them over an extended period of time. And so you can be tracked even though you think you're not being tracked, you're in incognito mode or whatever, in private browsing, depending on the browser you're using, you can still be tracked using these favicons. And so you think they're just a decorative resource icon, supported by browsers to facilitate some branding, but research demonstrates that they introduce a powerful tracking vector. It poses a significant privacy threat to users. So that's interesting that they're getting around when you're trying to either reduce your reduce the actual tracking that's being done by different websites, and going incognito or clearing your cache, different things to try and reduce tracking by sources like Google, and also your broadband provider like Comcast. They also track anywhere you go. So there's other things that you can do that can allow you to try and be less or more incognito. One is a VPN. You can create a VPN, and that blocks at least Comcast from seeing where you're going out to. If it goes beyond their initial point, beyond Comcast, so they can't see it. And then the other is when you do searches, use something like DuckDuckGo instead of Google or Bing. And that way, every search that you do on those is not being tracked, logged, and sold to third parties for them to do research on different types of ads to give to you. Of course, every day our phones are being listened in on to your phone's microphone is on all the time. And so it picks up keywords, and then you're going to get emails and advertisements based on that too. So Apple does the same thing. And if you don't believe me, then say a bunch of keywords and see what happens. Something you would never say, maybe like motorcycles. Start talking about motorcycles, this and that, motorcycles or something, and then see what type of advertisements pop up on your phone, in Google, in Facebook, and you'll see that you can get ads based on those specific keywords that you say. So, all right, that's our little technology moment. Today, we want to dig into Cisco's packet tracer. Okay, so I'll share my screen and everybody can pull up packet tracer. We should all have had it installed by now. And we're going to do a packet tracer lab that's in Moodle for this. And so let me share my screen with you. Okay. So here is Cisco's packet tracer. And all right, so pull that down here. All right, so let's start from the beginning. Hopefully everybody can get on this. Does everybody have Packet Tracer installed? All right, I'm going to take that as a big yes, and we'll jump into that now. Okay, so all right, I had to kill Teams for my last class. I got Teams, and Teams runs in the background while I've got Zoom running, and then it goes crazy. So yeah. All right, let's see what we can do here. So here's the main screen with Packet Tracer. And we have both a logical view and we have a physical view. So you can zoom out. Let's say this was your home city, and this is where you lived right here. You can then say, okay, in my home city here, oops, minus out. Then you can go to this and actually add in a corporate office, and within that corporate office, you can have multiple corporate offices. Inside this is your actual physical rack. This is where your equipment gets stored, right? And so logically, let's first put it together. And let's say we have 2 sites. So first we want to have a router. Go to network devices, and we can pick like this 1841 router. Okay. And actually, let me launch this again. Okay, let me launch this again because I want to launch not that, let's install. Let's try it again here. Tracer. Wait, because I am a little behind. Here we go. All right. So I wanted to have the numbers the same as yours because I've been putting in different devices. It keeps track of the devices. So if you put the first router will be 0, router 0. And so now if I go in and drag up this 1841 router, it is router 0. So I was plugging them in, it said router 6. So let's do another one. And let's drag up another one. So here's router 1. And we can put, we can do an actual, let's see, draw a line, or you can actually put in specific comments. This is it. Place a note. And this is our network. A over here, right? And oops, network B over here. And all right, sorry, I got to escape out of that. So here's our 2 networks. And move this down here. Okay. Network A and network B.
How did you insert those comments?
So up here above where it says physical, there's looks like a little black piece of paper. It says place note.
Oh.
And so I clicked on that. And then wherever I click, then I can add something. Like if this is 192.168. Maybe this is the 100 net. And over here, 58.200 net. Here's our 200 net. So, okay, so here are our Here's some notes we can add to this. So if we have a router that connects two sites together, then we can, we also need switches. So over here in the bottom left, it says networking devices. That's that first box on the left there. And then underneath you've got routers, you got switches, hubs, wireless devices, and so forth. So we click on switches and let's pull out this 2960 switch, and we'll pull out another 2960 switch. So now we got router 0, switch 0, router 1, switch 1 on the right. And then let's add some things to this. So if we go to the next device over, this is end devices in the bottom left. So end devices, we're going to need, let's do a PC. Okay, 1, 2, or 0 and 1, and then 2 and 3. So, all right, here we go. And here is our subnet right now. So now we want to connect all these together. So there's this little lightning bolt connection. It's a orange lightning bolt over on the bottom left. And this shows you all the different connections here. This is automatic, the lightning bolt. The very first one is that. Then the next one over is the console, that blue one. The black one's the copper, straight through, like UTP, unshielded twisted pair. Here's a crossover cable. This orange one is a fiber, or yellow, maybe that's yellow. Phone line is that zigzag dotted line. Here's a coax. Red is serial DCE, serial DTE. These are wide area network connections. Octal, IoT custom cable, USB. So these are your options here. Well, if you click this first one, okay, it is the lightning bolt, and it gives you this little plug, and it allows you to connect. You click on one device and to another device, and it automatically connects it with using the right connector. So I keep clicking on that lightning bolt, and so I'm going to connect these up using a lightning bolt, connecting these together. This is how I want them to connect together. And I need this switch to connect to the router. All right. And I need these actually to connect to each other as well. Now, this has some red, and this says fast Ethernet. And these are fast Ethernet 00, fast Ethernet 01 up above. This is right here. These green ones looks like are fast Ethernet 01 and to the PC, typically a copper cable. So this would be connecting two networks together logically. All right, is everybody here? Any questions on this?
Just to know that you mentioned copper cable, the actual wiring diagrams would mean between areas, and then the patch cables are not necessarily noted differently.
Yeah, it's smart enough for that. In fact, if you click on this PC here, or any of these devices, up comes the actual PC. A little picture of it. You can kind of see what it looks like here. Looks like you've got a connector there, an RJ45 connector for a copper connection. That right there might be a phone line or another copper connection. And so on these, you can add different devices. Here's a microphone, headphone, here's a cover, and so forth. What's this? Here's a Cisco Gigabit Ethernet network module, and so forth. So you can change out modules. It is aware that it's turned on. So just like you would turn off a PC before you worked on it, you would need to do that with this as well. And I think this button here, if you click the little red button, it turns it off. And then if you had like a gigabit, let's see, can you connect it there or maybe down below? You can throw on something else. Fast Ethernet. And then you power back up by clicking that button again, powers it back on. So if we go through these screens, you can add and remove components to your PC or laptop. You can go in and you can add the configuration settings global and on the specific Ethernet interface. And then you have this desktop. This is the third column over. And this shows you all the different things you can do. So different interfaces. You've got, you can go to the terminal or a command prompt. You can go to a web browser, things like that. Okay. All right. So if we go back to config, this would need an IP address. Well, let's see, what was on? Oh, I was on here, sorry. Oh yeah, and I removed my connection. So I need to reconnect it there. Okay. So if this is the 200 net over here, and this is the 100 net over here, let's then start with some logical connections. Okay, we can go to the router and we can go to the config and we can go in and we can set specific interfaces. And this is, you got a fast Ethernet 00 and you got a fast Ethernet 01 on this. Well, if I look at this, let me kill this. This is fast Ethernet 00 on this router. And this one's fast Ethernet 01. So let's make this WAN link 10net 10.1.1.0. Maybe that's our /30. And I guess actually, oops, /24. Remember that's just a /24 is just basically 24-bit mask, just like we've been doing. This is a 30-bit mask. Okay, so let's go into this. Let's go to interface 00. That's the one here for our local area network. All right, and I don't think I can, yeah, let me try this. Local area network over here. Local area network over here. Just kind of reminding us what we're doing. Okay. So I go to this fast Ethernet IP address 192.168.100. And let's say the router is going to be 1.
You wrote 99, 199.
Oh, thank you. That would be a problem, wouldn't it? So now here's my 192.168.100 net. I am .1, or the router interface is .1, and the subnet mask is this 24-bit mask, 8 plus 8 plus 8 bits. 8 times 3 is 24. So here's 24-bit mask. That's a standard class C mask. And then on the top, well, that's a WAN. So this top one is going to be the 10 net, 10.1.1. And let's use 4 and 5 or something. So it'd be 0 and 1, 2 and 3, 4 and 5. Let's do 4, and the other side will be 5. And
I think it's 5 and 6. I think 4 is your network ID.
Oh, thank you. And so this is going to be a /30, and it's going to be a 252, right?
Yep.
Okay. So let's try, is that a comma or a period? Okay, let's try that. All right. All right, so now we got this. We got this router configured. It's kind of grayed out. That means that's the one selected. Okay. Now, if I go back to it, it shows I've got an IP address on these, but the link is down. And so I have to actually enable that. Let's see what we got here. Did I enable this? Oh, you know, I have to turn it on. There's a check mark that turns on the interface up in the upper right. And I did not do that. So now I check that and that turns it on. Okay, now when I highlight, when I hover over this, okay, see how it says, sorry, if I'll keep my cursor the same. Oh, I got to move it a little bit. It shows me.
Do we turn both of them on?
Yeah, turn them both on, yeah. So now if I do this PC and I go to config, and my gateway now is going to be 192.168.100.1. Okay. And we don't have a DNS server right now. We can put one in here. Do 1 dot, you know what, we'll do 1.2. Okay, so then if we go down here, sorry, here. Okay, I'm going to do a static IP address for now because I don't have a DHCP server. 192.168.100. I'm going to make this PC 3. Sorry, 3 because 2 is my DHCP server.
So
Sorry,
you have a
DNS.
2 stuck in there.
Oh yeah, thank you. 2. All right. All right, so this is already turned on by default. All right, now if I go to this desktop now, and I go to a command prompt, and I do ping 192.168, I want to ping the router, 100.1, you see it's communicating now. All right.
Sorry, can I look at these settings for the PC again?
Yes. So I'll click on the PC. Sorry, let me go to config. And in global settings, I've got a static IP address for my gateway, 192.168.100.1. That's the IP address of the router. And I put in a DNS server, even though we don't have one yet. 192.168.1.2. And then I went to my interface. I went to the fast Ethernet interface right here in the upper left. And under that, that's my actual NIC card. And on the NIC card, I want to set up an IP address of 3 or 100.3. So I plug in 192.168.100.3. And that's a 24-bit mask. So 255.255.255.0. And then, and it's already turned on up in the upper right-hand corner. You see that that is turned on. So it's already enabled. And then I just do, I did a ping there. And so I am pinging my gateway there. Is it dash T?
Yeah, well,
T?
if
Persistent?
you do it,
No, it's a
if you
slash.
dash T.
It's slash T.
Oh yeah, slash, not dash. No, no, try dash. Mm,
No, it's, slash T. T as in Tango.
yeah,
Well, it may not. You see, the thing is, it may not support.
yeah. It might not be the exact Windows ping command.
Yeah, when it's a simulation, sometimes you don't have every option available in a simulator. So maybe that's the case. Because I could do
You
ping
open the command prompt in this case.
question mark.
This okay, I see. Never mind.
You can do a count.
Let's try that. Dash N and 30.
Oh, slash T. Not only slash T, but hyphen T also working.
Oh, well, you only. I should probably put in the IP address here. So 100.1/N30. Does that work? No.
You got too many N's in there.
Yeah. You
Oh, I
said
see. Sorry,
ping
sorry.
and yeah.
Thank you. Try that. Okay, 30. Ah, got it.
There we go.
Okay. So this is pinging from the PC through the switch and to the router. You can see, maybe you can see, but sometimes it blinks with the data with those little green arrows through the PC to the switch to the router. And I didn't do anything with the switch. By default, switches, the ports are enabled and turned on, and I don't need an IP address for the switch. That's for management. Switches are layer 2 and just look at the MAC address. So that is communicating. And if this guy down here is 3, right? Well, then this guy over here, oops. We'll do his as 4, right? Okay. So here's 4, and here's 3. So let's click on him. Let's go to config, settings, gateway. So hopefully everyone is doing this now along with me here. That is my gateway, and I'm just putting this in, even though this makes no difference at this point. But it will once we add a DNS server. And then I go to Fast Ethernet. 8.1, oh, sorry. 100.4. It automatically goes into subnet mask for me. So from this guy now, if I go to desktop and command prompt, now if I ping from PC1, it is talking also to the router. Okay. All right. So now we've got the same thing here. We've got these two networks here. And that kind of looks cool. All right. So now we've got these two here set up. And we need to do the same thing for network B. And with that, interface 00. .1, that's the actual subnet mask there. And my fast Ethernet 01 is going to be 168 dot, oh, sorry. It's a 10 net. 10.1.1.6. All right, with a F2. Okay. Oh, what I didn't do? I've got to enable these. Got to enable these ports on here. Put those check marks in there to turn them on. By default, the router's ports are not turned on automatically. You have to do the command is no shut, but anyways, you see the no shut down right there, down below, and the equivalent iOS commands. But yeah. And if I then give this guy a IP address, and default, fast Ethernet, let's go IP, because that was the IP version 6 there. So 192.168.200 dot, and this can be, let's do this as 3, I guess, as well. Okay. And then this one here. Settings. So if I go to desktop, I go to command prompt, ping the router 192.168.200.1, number of pings 10. And we see I'm pinging from now network B from PC3. Okay. So we want to ultimately be able to have communication between PCs 0 and 1 on subnet or network A, subnet A, to be able to communicate up to the switch, to the router 0, over to router 1, down to the switch, and then communicate or ping to PC 2 and 3. So right now, if I try to ping the other, that's just 100 actually, 100.1. It's trying to ping, but it's not pinging. Anyone know why?
Because there's probably a setting of the connection between the two routers.
Yeah, we've turned these two interfaces on. We've given them an IP address, but I was trying to ping down here to router 0 interface, and that is not directly connected to router 1. Router 1 is directly connected, so I could do an up arrow and I could do a ping to 10.1.1.6. That's connected on router 1. That's the wide area network connection. Does that work? Yes. So I can ping the other interface on the network on the WAN side. That's a 10 net. Okay. What about, if that's 6, what about 5? That's the IP address on the WAN interface of network A router of that Cisco router 1841. Let's try to see if this works. No, it's timing out. So for it to have a route, it actually has to pass routes to one another. These two routers, when you send the ping up to router 1 here, okay, the 192.168.200 net, well, it knows about that and it responds right back. But and it knows about the connected interface .6, 10.1.1.6, because that's connected to the router, but it doesn't know about these other connections, because this connection here doesn't know how to respond back to that. There's no route back to this LAN subnet, which is 192.168.200.0. So actually routers have to actually share routes to subnets. They have to share actual IP address ranges, or these subnets with each other, to get the routes between different routers and between these different subnets. And so you actually have to have either a static route that says from router 0 to get to PC3, I have to go to the next hop, 10.1.1.6, which is connected to 192.168.200 net. And then on that net, I find PC3 at 192.168.200.4. Okay. And so that's what has to actually be done with these, is when you go into the router here, you can turn on, and you have to actually share these routes. And
Was that 5?
I have to share that I have 200 attached to router 1. 200 is over here on the right. I have to share that network out. Okay. And then also on this one over here, I have to do the same thing with RIP, which is a dynamic routing protocol. Add that one. That's the WAN group, and then 192.168.100, which is directly connected in the back end over on my LAN on this one. And when I do .0, that's a network ID that I've identified, that LAN for 192.168.100 net. So add that. Okay, now I'll go to this PC. Can I ping 10.1.1.5? Now I can ping 10.1.1.5. And in fact, I can even ping a PC clear over on the 100 net now, 192.168.100.3. And I'm responding. So I'm going from subnet 2, or network 2 here, or B, I guess B, the 200 net, going up through the switch, up to the router. They've shared dynamically the routes, their LANs amongst each other, the two routers, with this dynamic routing protocol. So now when I send it over, the router 1 knows, hey, I know that the 100 net is behind this WAN, this 10 net WAN connection. So it sends it, this router picks it up and can route it back. And it says, I know 200 net is behind this 10 net WAN connection too on the other side. And so it makes the round trip. And now I'm communicating on both sides here, all the way across. This WAN could be a location like one office building and another office building, something like that. All right. Any questions with this right now? Any, or were somebody got stuck and they got lost, or any questions?
Professor, can you show the IP settings for the fast Ethernet and the global settings for the PCs again? I think I was a little bit slow.
Which fast Ethernet do you want to for the routers?
For the PCs.
PCs, okay. So let's go to PC 0 here. and we'll go to config and fast Ethernet. So what I had done is I had stuck in the IP address of the gateway, which is the router interface. That's the IP address of this router 0 over here on the left on network A. And I have a DNS server, which I have not added yet, but I will. And then I went to up the global settings. So maybe you're missing that. Global settings was the gateway and the DNS server. Sorry. And then the fast Ethernet was the here. This is the IP address of the actual network interface card on that PC0. So that PC0 IP address is on the NIC card, network interface card, and then the subnet mask, which is this 24-bit mask, standard class C, 255.255.255.0. 8 binary bits make up those 255s in those first 3 octets. Those 8 bits, 8 times 3 is 24. That's a 24-bit mask. That's why I wrote it out as this LAN here /24. Okay, so I'm using the global settings. I made some changes, and I did the fast Ethernet here.
Sorry, can you show the global settings again? I
Yeah.
was writing it down.
Oh yeah, global settings. Okay, so global settings. This is for the fast Ethernet interface, which is the only one we got here. I did static, and I gave it the gateway and the DNS server. Now, you see how long this took us just to configure this. If this was a real network, it would have taken us, we'd have had to been on this PC, brought up this configuration, actually typed in that information, and we would have to manually set up all this information. And at least for your PCs, that's a nice element of dynamic host control protocol, is that if we have a DHCP server, well, then we can be given these IP addresses dynamically for the 100 net or the 200 net. So PCs 0, 1, 2, and 3 on these 2 subnets can get an IP address, and the DHCP server gives the DNS server, gives the gateway, gives the IP address, and gives the mask. It gives all those things. So these 4 elements that I set up manually in global settings, the 2 there, and then down on interface, fast Ethernet 0, these 2 settings, the .3 and the mask there, that 24-bit mask, that would have been given to me from DHCP.
Also with DHCP, the at least on an enterprise one, you can set up a network time protocol server information on it too. So it hands that out to your client computers, as well as any other server you want to put in there.
That's right, yeah, because then because when you get a lease on an IP address, they kind of lease it to you for only so long. I mean, you specify that on the DHCP server, but by default, it's like 8 days or a week or something. And but it can be a very small amount of time. I think I've seen when I've been on wireless at St. Martin's, I had like a lease for like 3 hours or something like that. Is that right?
Depends. A lot of times we'll put it up to 8 days or so. But if we were going to do some changes to DHCP, we're going to make the lease time a lot less so that your computer is forced to update it.
Oh, that's smart. Yeah, let's say you take the lease and you have a couple hours or an hour or something, and then you make a change which totally changes the subnet or the mask or some element that the DHCP server gives out. Well, then it's just going to update the address automatically, and it's going to get the new address. Nobody's the wiser, right? Unless that person that tries to get out right when you make the change and says, Oh shoot, I can't.
When you're a sysadmin and a network guy, if you do your job right, nobody knows you did anything.
Yes, right. you can make change in the middle of the day, right?
Yeah.
See, normally what you'd have to do then is to make sure nobody's really affected is Peter would have to wait until later on, maybe in the evening or something, when nobody's at the university, make the change, and then when people come back in tomorrow, it's all changed and nobody was affected. But that means Peter has got to come back late at night and do the cutover, right? And
they may actually have to restart their computer if I did it by hand,
sometimes,
so they'd come back in the morning and nothing would work, and I'll just reboot your computer, and they wouldn't know. So yeah, it's definitely helpful to be able to do things automatically.
Yeah. Okay, so has everybody gotten this? If we go to desktop and we go to this, everybody's gotten these to actual ping each other? Are we getting a ping command right there like that? I just Control C and break out of that ping command. And if you're on one box, pinging from one side to the other. So if that's 192.168.100.3 and 192.168.100.4, this 100 net. These other ones are 3 and 4, but 200.3, 200.4, right? So 3 and 68.200.4. So here's these. So can you ping from one side to the other? Are people being successful in doing that?
I think everybody's asleep.
Mark, I wanted to just basically lock down, obviously, when you're putting the DNS numbers in early, are you doing that as a method of just putting a place marker in so that you later on go, okay, I'll now go ahead and focus on that DNS edition? Okay.
Now, if I go back down to these end devices over in the bottom left, and I click on a server and I drag it up here, okay, this is going to be my DNS DHCP server. Okay, so I'm just going to escape out. Here's my DNS DHCP server here. So I'll click this little connector, put it to the switch. Now I've got a server. If I go into the server, okay, now I've got to do the config on this. Settings, I got to get my own settings in here. 192.168.100.2 was the IP address we gave it, right? And, default gateway. And then 192.168.100.2. Well, it is the DNS server. So that goes there. It's the same IP address for it. If I go to interface, then I've got its IP address, which of course is the same thing, 100.2 with that mask. And now I got to go to services and I've got to turn on DNS on. Okay. So I can put in, I'm going to put in stmartin.edu. Let's do 5. Okay, there's a website, and I want to put it in 100.5. record add. So I've put in my DNS a record here, stmartin.edu. Let me add in another one here. 192.168. 200.
Don't you need to put it in the address, not the name?
Oh yeah, that's right. Yes. Let's do one of these PCs over here, PC2 or something, and that was 200.3, let's say, and this was PC2, PC2.st. Oops. Maybe I should have done this one and gone. Save. Okay. So here's 2 records in there. And maybe this is also the DHCP server. So one DNS server. Well, two. And the DHCP server, where should these start from? If 1 was the router and 2 was the DNS DHCP server, well, 3 could start the ranges, or maybe we just start those at 10 or something like that. Okay, 10. All right. And then add. Oh, pool name already exists. Save. Okay. All right, I have 2 things on now. I have DHCP and I had DNS. Those 2 services are on now. Okay, now if I go over to, let's see, this is the one I already created. I go to config, I put in the DNS server, right? So if I go to desktop here.
It's not the right address though.
Oh, thank you. You see how those little slip-ups can cause problems?
That would definitely not make it work. So
Yes. So now, okay, now I have a DNS server and okay. So here's this, and I go to desktop, and now I want to go ping, but I want to not give an IP address. I want to say pc2.stmartin.edu. There it goes. So I pinged that PC2 on that other subnet. I'll break out of it. Control C, I'll break out of it. So I'm pinging the other PC. It took a minute to resolve. It says, oh, you're pinging pc2.stmartin.edu. What is that IP address? So it goes to the DNS server. It resolves pc2.stmartin.edu is 192.168.200.3. It starts pinging. It took too long, so the first ping timed out, but then it picked up because you typically have a timeout of 2 seconds. And so this simulated thing, then it starts responding. I have that -n for number of pings 30 on there. It's not necessary, it just goes 5, of course, by default with a PC, or 4, I guess, by default, 5 with the network anyway. So yeah, So now it's pinging by name. Now I have a working, resolving server for DNS and DHCP. So let's test DHCP.
Hey, actually, before we move on, can I ask a question on DNS server? So for personal computer, I always put 8.8.8.8 or 8.8.8 4.4. I know those are for the Google. How the DNS server for Google will work for the personal computer?
Okay, so in this case, this new DNS server was what's called the start of authority. It knows all IP addresses associated with these two subnets. Let's say this was St. Martin's, and these were two subnets in say different buildings, or one was here and one was up at JBLM or something. This server, DNS DHCP server, it owns all the IP addresses associated with St. Martin's. And so what would happen is this DNS server, if you want to resolve anything on our intranet, which is LAN plus WAN, all together, you want to go here because this has the IP addresses in its DNS. When you want to go to the internet, like a Microsoft or Amazon.com or something, it doesn't own those numbers, and it has to find those numbers from other DNS servers that resolve name to IP. So Microsoft.com has to go out and resolve that. So you would have to have a forwarder. You would need a forwarder from that DNS server. You'd have to forward to 8.8.8.8 or 8.8.4.4. And then that DNS would then traverse the internet through what's called a DNS recursive search and find the IP address to Microsoft.com. And then it would give it back to the PC so that the PC could go to that IP address and go to that website.
Oh, so basically those the Google DNS server is behind the scene of the DNS server that we have on the map.
So this is exactly how it works at St. Martin's. You want to go to a server on St. Martin's, well, their DNS owns all the IP addresses for St. Martin's that have been allocated to St. Martin's and so forth, and their private addresses. So that would resolve anything St. Martin's, but then when it's not part of its domain, a separate domain, a Microsoft.com domain, a DNS domain, that it doesn't own that, so it goes out and forwards out to the root DNS, and it finds the COM top level domain, then it goes to the actual DNS server for Microsoft, and the Microsoft's DNS server then is going to respond back to St. Martin's DNS server and say, here's the IP address. And then our DNS server, or actually it's the resolver portion, would then resolve and then give back to the PC the final IP address. And that goes in what's called your DNS cache. It's actually your DNS or DNS resolver cache. And that resolver cache stores all the IP addresses you've gone to, name and IP, so that for a certain amount of time, so that if you go there again, you don't have to look it up again like that. You just got it.
Yeah,
Great,
the
thank
way
you.
the way I would look at it is here on campus, the DHCP server will give you a local address for a DNS server, one of our DNS servers here on campus. And yes, that will resolve things that anything to do with stmartin.edu, but those servers are then tied into the other internet DNS server system, so that you can get other names, like google.com or amazon.com. It will resolve those for you. When you put in 8.8.8.8 or 4.4.4.4, you're basically setting your computer to use the publicly available DNS system that's out on the internet rather than a local one. And that's the only difference.
Okay, thank you. I'm sorry, I'm asking too many questions.
Go ahead.
Yeah, next question is is there any specific reason why you put in the switch is like on the left side switch, can it be right side or layer 3 router?
You could use a
So
layer 3 switch, sure.
yeah, you could do now if you had when you say layer 3 switch, that's a router and a switch combined.
Yeah. So what I meant was like, is there any specific reason why that the DNS or DHCP server is under the 100 subnet instead of 200 or instead of the
No,
router?
that was just a architectural decision I made.
Okay, so
Stuck it on
you
the
can put it
200.
anywhere.
Yeah. Mhm.
You can put it anywhere. You just have to configure it properly in order to talk. Because DHCP only works through broadcasts. You have to forward those broadcasts over to the 192.168.200 network for them to get an address.
Mhm. So
But
under
the broadcast would go through to 100 without doing anything. Does that make
Oh.
sense?
yeah, so for the 200 subnet on that instant, but since the DNS and DHCP is configured as 100, so the 200 subnet computers will not be utilized at DHCP since it's set it up
Correct.
as, I see. So you need another separate DNS or DHCP
Right.
for, okay, got it.
Yeah, the DHCP
You need
server.
another
You
server
can
pool.
also create
I see.
a 200 net here. 200 starting at 10 and add that. Let's see.
Yeah, you got to change the name.
From the what up here, server pool, you mean?
Yeah.
Okay.
You got to make
Well,
it server pool 2 or something.
if this is the 200 net, okay, and I save this.
Oh, you have to add it, right?
Oh, I got to add it here.
It's already added it.
You got it.
Expand this out a little bit. Okay, server
It figured out what you wanted.
Okay. Now this server pool, I'm going to change this to say 100 net. Okay. And I'm going to save that. Oh, I see. That's interesting. Did it do it? Oh, get still server. Okay. Let me highlight this and
delete it. Yeah.
Can I remove it? Removes grayed out. I'm not sure why.
Is it
Weird.
because the service is on?
Oh, you know what? Yes, it probably is.
No.
Okay, let's leave it
I
here.
don't know.
Let's see what happens. What I'm going to do now is I'm going to go to this PC here, and I'm going to. So this is this PC1. I'm going to go back to config, and I'm going to say DHCP, and I'm going to say fast Ethernet here. I'm going to say DHCP as well. And you see how it started with 10?
Yeah,
You remember
it
how our
issued you
range,
that first
range
address.
from
Yeah.
10 up? Remember that? So it now, instead of giving it a 4, that was our statically assigned. I said my range is from 10 up. And so it gave me the first dynamic IP address in that range, which was 10. So now it's giving me 10. And the settings up here, when I did DHCP, it gave me default gateway and DNS server from the DNS server. So dynamically, I'm getting these two things and the IP address of my box and the subnet mask. So now still, when I go to command prompt, all right, and EC2.
Will it be the same IP address for everybody?
No. Everybody gets a different one.
Okay.
Yeah.
It'll be fun.
Yeah, everybody has to get a different. So here's what I'll do with the other one. I'll jump over to this guy, PC0, and I'll go to config, and I'll go to settings, and I'll go to DHCP, and now it's going to give it, and I go to interface. It chose 11 because that's the next address in line. See that? 11 right there.
Well, I mean, for mine, it starts out with completely different numbers.
Okay, that's fine. But what I did is when I went into this DHCP server here, Okay, I went into DHCP right here, and I said, I put this as 10. I put the starting address as 10. 192.168.110. And so now when I go DHCP, well, it's never going to be lower than 10. So that 1 through 9 are statically assigned. 1 is my router, 2 is my DHCP and DNS server combined. That's, they're both, those services are both together on one server. But I could add, 3, maybe for a management IP for my switch. Maybe I could do a statically assigned voice over IP phone. Maybe I could do a wireless access point, and those would be 4 and 5 and 6. So I started my dynamic range for DHCP for my PCs at 10. That's why that PC1 got 10, and then PC0 got 11. Does that make sense?
Yeah, thank you.
Yeah, so whatever number you put in as your start IP address, that's where it's going to start. I mean, I could have put 50 there or 100 there, and then I would have got 100 and then 101 had I done that. And of course, you have a Class C, so you have a range of usable 1 through 254. And but I've already got a couple statically assigned that I don't want to overlap. I don't want to give a 1 out because that's already my router. And I don't want to give 2, that's my DNS DHCP server. And so that's why I threw in 10, but it could have been any range there. Starting address. This is simplistic. In an actual DHCP server, you would give a range, and maybe the range is 10 to 50 or something like that. And then only within that range would it give out dynamic IP addresses to laptops and servers and stuff.
And if you notice, Mark did something really smart here. You got, like he said, the first 9 are static address range, and the rest of them are the dynamic address range. You don't want to have those overlap because the dynamic one, it can assign a computer to, say we had it in the 3 to 5, 3 range up to 246 instead of 10. And so it would have handed out 3, and then we would have had another computer statically assigned with 3, and that would have been an IP address conflict, and it would not have communicated. So best to keep your statics static and you keep your dynamic hosts in the dynamic range.
Mark, I have a quick question for you. Let's say in this example you have, which is very simplistic, on your 100 net, you've got 100.3 and 4. Let's say you added 2 more, like a 100.5 and 6 or something within that small group, but you wanted to separate out those PCs from actually being accessible to the other 2 because of security reasons. Is there something in the switch configuration that we can do to mark them as separate, or is that beyond the scope of what we want to achieve with the simple model?
No, well, if you let's say I had some laptops here or something. All right. And I don't want these to be on the same subnet. Okay, I can connect these to the switch. Okay, sorry. But if I connect these to the switch here, okay, here's my 2 laptops. But if I gave them, let's say that this was maybe like a lab or something. Let's say this is a lab, but they needed to communicate amongst themselves, and they didn't need to get outside of their lab. It was just an isolated lab. Then I could give them an IP address that is not the IP address that or range that these other 2 PCs are on. Okay, because if I gave them a static setting here, okay, and I don't need a gateway because they're just going to talk to each other. Okay, and I went to this fast Ethernet and I did 172.16.1.1, okay, and then this other guy, okay, I open him up and I do this config here, 172.16.1.2, Okay. So now when I go to my desktop and go to a command prompt and I do ping 172.160, sorry, 172.16, sorry, 1.1, because I'm on 1.2 right now. Okay. It's pinging. I'm talking through the switch to each other. But if I do this 192.168.100. Let's see, it's not 3 anymore, it's 10, right? Because I assigned an IP address that says, in this config, I said, this is my IP address and this is my subnet right here. Okay, I could have been 255.0 if I wanted, but it's basically saying just these IP addresses from 172.16.1.1 through 254 are usable and are part of the subnet that I know about as a laptop. And in fact, the other PCs, they don't know about the 172.16 net either. So these two boxes are totally isolated, even though they're right on the same switch. They're right on the same switch here, but they whoops. Let's try this again. This is a laptop. What is this one? 2 or 1? I'm confused. Okay, let me go to this one. What did I put? Oh, this one's 1.2. So the other one's going to be, you know what? This is going to be 1.1 because it's laptop 0. Okay, and the other one's going to be 2. That'll help me. Just got to make this so I understand it. Okay, so now this guy, Fast Ethernet, this guy is going to be 2. And okay, so now you've got these two, 1 and 2 on 172.16 net. They're on the same switch. They could talk to these other PCs, but they themselves, the operating system that's running, does not know that there's anything else besides 172.16 1.1 through 254. So they don't know about them. And so they can't talk to them even though they're plugged into the same switch. And it's not partition or anything. It's literally the subnet that you just created is isolated. And not only that, but when this packet goes out and like I want to get out somewhere and ping something else, I don't have a default gateway. Even if I can't put a gateway because the gateway is not in this range of 172.16. So it won't ever send it to the gateway because that's not on my subnet. So I can't go anywhere. So I'm completely isolated. Does that make sense?
If I understand you correctly, then the mere act of putting a subnet mask in as you have, it assumes that range, that 0 through 254 for the IPv4 that you've got. So it assumes the 2 is legit, and then puts the range around it with the subnet, and the 2 will never see each other, for the other. That makes sense.
That's exactly right, because you define the boundaries right there by putting in those 2 numbers, the IP address and the mask. You just defined it, and the operating system doesn't think there's anything else besides the 172.16 1.net, a 1net there. And
that's essentially like a command path. I mean, the path is limited just to that range. So
yeah. And the only way I'm going to get out is because the router defines a subnet, the actual subnet out. Okay, that's the actual gateway until I change it to a 192.168.100 net. Okay, then now if I just do DHCP, see what happened?
You get a correct address now.
It just corrected it for me. I did DHCP. It sent out a broadcast, and a broadcast says, I don't know what's out there. And the broadcast was to the 255, 255, 255, to the all broadcast. It sent out and it sent it to every PC and DNS server right there. Which is the DHCP server. DHCP server picks it up, says, oh, DHCP request DHCP DHCP discover broadcast, and it responds with a DHCP offer. And what's the next available in that dynamic range? 13, because I've used 10, 11. I don't know where 12 went, but that's 13 now. So yeah. So it gave me 13, and now this one is just like every other one. So just by doing that, I can ping, pc2.stmartin.edu, and that's going to respond over to the 200 net over on the right and ping that PC2. So we've added a few more. We've added some laptops now. And we've added a DNS DHCP server to resolve name to IP. We can get dynamic addresses now because we have a DHCP server. And let's see, devices, server. Here's another server. Here's a printer. Here's a how about
obviously an HP printer.
Here's a wireless. Here's a voice over IP phone. Here's a wireless access point. Is that right? So yeah, so now we got a wireless access point. Okay, I gotta click on this and see. Okay, I gotta figure out. Maybe I don't want this. Oh, wireless end device? No, I don't want this. And this little X will start killing stuff. Like if I click on this, it'll kill it. So be careful. You have to press escape. If it's got that X, press escape to break out of that. Okay, let's go to this server here. And let's go to config. And this is going to be our web server. Web server. All right. Static. 100. Dot, what are we at? 4? Or now we've got 1,
Well,
2.
default gateway would be 1.
Oh yeah. Two, and then this interface. And this is going to be 1, 2.
You could use 3 again.
We can use 3 now because 3 was opened back up because this guy down here is not 3 anymore. It's actually 10, right?
10. Yeah.
And this one is actually 11 because it's dynamic now. Those aren't static, so like you could get another one in that range, but anyways, so I've got to connect this thing to the switch, and I've also got to turn on the service for like a HTTP web server. So if I turn those on, okay. Let's see. 3. All right. If I do this, and what was my DNS? I had this as 5, didn't I? Sorry. I had this as 5. Sorry.
Yep, I had forgotten.
Yeah, so I forgot. That's okay. So now Let's go to this PC over here. Let's go to desktop. Let's kill this. Let's go to web browser. And let's go www.stmartin.edu. Hostname unresolved. Oh, stmartin.edu.
I would check your DNS settings for the config.
On this one? Okay.
Yeah, because it's not a DHCP, it's static.
Oh, okay. You know what? I'll just do this.
Well, yeah, the broadcast won't go across, so you can't do that.
Oh, I need a helper address, don't I?
Yep.
Okay. So let's do static for now. 200.1 and 192.168.100.2 and this was 3, right? Oh no, 4. This is what I'm on. I'm on 4. 4. Okay, let's try this. Okay, now go to desktop. Try this. Go. There. Packet, Cisco packet tracer. So if I go back to this web server, so you know it's actually working, and I go to services and go to HTTP, and I want to edit this index file. If I edit this thing and say, Cyber Saints, but I put an S there. Okay, so now I save this. Yes. Okay, now I go to this guy and I do a refresh. Go. See? St. Martin's University. I spelled university wrong. Cyber Saints. You see how I just edited that index file, and now when I go to the website, it resolves for me the IP address, goes there, pulls the index.html file down to my browser, and now I'm seeing what's on that website here. Okay, so we're out of time. It's 2:20.
Yep.
Okay, we are going to we're going to follow up on Thursday with some more of packet tracer, and then we're going to have a specific lab for you to do, and each of you can then, if you go in and you save this file, oops, let's just do this lab, save. Yes. So now if I go to file and recent files, you see this here, this users, C:\, users, mwrite, Cisco packet tracer 7.3.1/save/ and then this PKT, this .pkt, this packet tracer file is your config, what we just saved in, and this is saved in the saves subdirectory under packet tracer, Cisco, under your name. And so that
Just
file,
upload that.
say again?
Just upload that packet file.
Yeah, that's what we want. We want that upload. Once you finish the lab, we'll do some more packet tracer on Thursday, and then we'll give you a lab to create very similar to this, and you can each then finish it and then upload your file to us for the lab. Okay. All right.
Right.
Thank you, gentlemen.